Yep, good morning you all. It's 10 o'clock. First presentation of today, also the last, so we see how much time I will take. The title is TRS-80 Time, and all of you have a hobby in TRS-80 and not enough time to do what you want to do. So I have the same problem. Still have that problem, but it's slightly improved. So one of the things I really didn't like was typing in time and date and booting a Model 2. And you can turn it off in LDOS and just say, don't do that anymore, but then you mess up your timing for your files. So the solution is put in a real-time clock. Real-time clock is not new. I mean, they are around for a long, long time. Also for the Tandy computers. But they require some hardware, the real-time clock chip itself, and some software to control it and to get the time from that chip into your system. For me, I made a list of requirements. Well, of course, since I do this for myself, I wanted to fit in the Model 2. The Model 2 has a nice small ROM socket, 2 kilobyte or 4 kilobyte of ROM, and you can put it in there. Of course, you can also put a real-time clock on the board and make an extra board to fit into the slot, or any other solution. But I didn't want to use I/O ports, and I didn't want to use a memory mapping. So this is a known thing. The Dallas Semiconductor chip was also used by Tandy smartwatch. So if you Google for Tandy smartwatch, you find all kinds of watches, but not this clock. Well, anyway. And for myself, I wanted to be able to use a 4K ROM as well. That works. And to make it look more or less like a ROM, also EEPROM works in there, even when it's soldered to the board. Yeah, the end product looks like something like this. A small board and a wire and a battery there. Only 2 chips, and underneath the small one there's the crystal for it. That's it. The end product. On a Model 2, you have your CPU, and next to that the DMA, and the slot for the ROM. So it's easy accessible, and there's plenty of room around it as well if you need to have some overhang of the board. So I picked the DS1315. They are available. You can buy them new. You can buy DIL versions. You can buy SMD versions. But I wanted to do some experimenting, so this is a DIL version. It's easier to swap. And I tried to buy them from AliExpress, and also that works. I bought like 20 and only 1 or 2 of them failed, so easy product, not high margin, obviously, so there are no fakes or very less fake. The way this thing works makes it possible to use this same design in any computer that has a socketed ROM for 24 pins. So it's not limited to a Tandy Model 2. You can use it in any Tandy machine. And there is also software for the Coco already, or from back then, I would say. And that makes it nice. You can also put it into a completely different platform. The thing that makes it difficult to use is how do you access a chip that is hidden behind a ROM or underneath a ROM chip into a memory. And they do that. They designed a sequence of 64 bits you have to send to the chip, to the ROM, by means of reading data from your ROM. And the real-time clock chip will monitor what's happening. It will be looking at the address lines. So if you send certain combinations or read from certain addresses in the ROM map, it will, after 64 bits, it will open up the registers for the real-time clock. And you can then read or write. The first time you have to set them, of course. So you have to set the time, and then it will run as long as there is power applied or runs from the backup battery. This is the drawing from the data sheet. The top shows the ROM chip, so it can be any size of ROM as long as you have enough address lines, and you need at least A1, A2, A0, A1, A2, so it can be a very small ROM. And what you see in the different colors is the way it is accessed. So although you have a ROM there and you never can write to a ROM, the clock chip has a write enable, and the write enable is connected to address line 2. So when you read something which has address line 2 high, it is interpreted as writing to the clock chip. So that's the way you can set data, and the data is coming from address line 0. So it looks like a weird thing, and if you read through the code, it takes some time to understand what's happening, but the documentation is pretty clear. And the other essential thing, really pointed out, is this one. There's a chip enable going to a ROM chip, which enables the output of the ROM so that normally the CPU can get the data out of the ROM. In the board, the chip enable is connected to a chip enable input in the real-time clock, and it is then connected or not connected to a chip enable output, which runs through the original chip enable of the ROM chip. So that's the only pin that has to be diverted from the socket. Everything else is connected in parallel. In normal operation, chip enable in and chip enable out are connected, so then the ROM is working as intended. Only when the 64 bits that open the real-time clock are received, this line will not activate and your ROM will be invisible. It cannot put any data on the bus. And then in the same way as you write data by a single bit, so you need to do 8 read accesses to write 1 bit, you also need to do 8 read accesses to read 1 bit. So the Q, that's the output, compared to the D as the input, the Q is output and goes back to data line 0. So in writing you have to split up your byte into 8 read actions, and in reading you have to assemble 8 bits back into 1 byte. The board has, the chip has the option of having 2 backup batteries. I used only 1, that's no need. And then there's of course the other component needed. That's the crystal. And if you use a small crystal, you can fit it underneath the chip inside of the socket. And if you don't use a socket, you can solder it on the underside of the board and use some hot glue to fixate it. Well, this is the sequence of bits you have to send. C5, 3A, A3, 5C, and that twice, and that's on then, and you have to create the bit stream out of the bytes that you have. That makes it a bit of a puzzle how to do it, but there is also sample code in the documentation for 88 processor or 8085, and somebody already made this, used this to make a Z80 code as well. And this is the way it works in assembler. On the left-hand side, this is the access routine that will eventually unlock it. So you have these 4 bytes over here, and for each byte, the write clock is called, and that breaks the byte into 8 bits for access. Of course, although the Model 2 is a rather large machine, you do not have a lot of space for a thing like this. What you see here is a picture of the Model 2 CPU board. On this side is the side of the cage, and this is the board in there with the ROM, or in this case a EEPROM soldered on it, and this is the real-time chip in the socket. So it just hits or does not hit the metal plate there. So ideally you would not use sockets, but okay, sometimes, and especially in testing, you use sockets anyway. Well, how do you save some height and also solve this, the way of how to put that little PCB into the ROM sockets? You use these kinds of pin headers. And when you look at this, you can see that this diameter is smaller than the top side, but you still have this on the side of the board. And what I did was, okay, normally you solder this pin in, and then this is a piece of distance that you don't need. So I designed the board with a larger hole, so this will fit in. You can cut this off, and then you have to solder it. The best solution would be use these lead frame pins. They are available. Difficult, but there are only 1 or 2 sellers, and the manufacturer sells them, of course, also, but in minimum order quantity like 50,000 of these things. So that's a bit much. But there is a guy on the internet that sells them by the 10 or by the 100, so for a reasonable price. The schematic itself in KiCad, I can show you later on if you like. I have it on my laptop. It's very simple. The slot the footprint for a memory chip, so 2K or 4K ROM, the real-time chip, the socket, which gets the pins to put into the socket, the crystal itself, the connection for the battery, and one little jumper that's normally always connected, which allows you to put in a 4K ROM, and with an extra address line also use it. I use it for my diagnostic ROM that I have. When you look at the design of the board, yeah, there's not that special. U2 is the big chip, and you see here the larger holes for these row headers. Over here, the real-time chip, underneath room for the crystal, connector for the power, and the little jumper, which is normally connected. And if you really want to use it, you just cut one wire and you put a header on it, and that's it. So these are the boards. I got them back from China just a week before I left for the States. When you send the Gerber file to have them make, they will sometimes even surprise you, because it only took less than 2 weeks for getting them. Sometimes it takes 6 or 8 weeks, depending on how busy they are. What you see here is the pin headers inserted from the bottom side, and you see here the thicker pins are clipped off, and you solder them in, and then they are really flush with the top surface. So you don't have to grind it or whatever. It's really top, and then you can put a ROM chip on it without problem. Soldering them in, normally I use a socket to adjust, because otherwise you like this, and that's it. And then here, this is the end result of this after soldering. It looks like this, and the little crystal within the socket, confinement. This is the final hardware solution. Really simple thing, nothing special. And this is how it fits into the Model 2 on the motherboard. When I designed the board, I just thought, okay, I have this much space, this should fit. So later on I show, well, it does fit, but do not have a lot of room. It looks like this is hitting the chip here, but you can still feed a sheet of paper in between, so there's no risk of connecting anything. And the battery is just you solder 2 wires to a coin cell, and that's it. Some shrink tubing and works. The reason I did not use a holder on the board is that it will take up space, and you're not that flexible. And although this is a real-time clock which should keep time for when you're not using it, I mean, we use our machines not that often. And you might want to take out a battery if it's not needed. So you just take it out, that's it, no problem. The software there was software written back in the 80s by Duane Saylor. I could not trace him, but I found out that he has died since then. I mean, back then I was still a small boy, so he would have been really old. He wrote software for the Model 1, the 3, and the 4, and for the 4, the platform was MS-DOS, which is nice, MS-DOS 3, because, for 6.3, because that also works on a Model 2. And after some digging, I found source code and modified it because the way you swap in and swap out a ROM chip in the Model 4 and in the Model 2 is not the same. And the interrupt handling is also a little bit different, so not too many changes, but I did that. And this was written in 87, so there was, all dates were 19 something, and now we have 20 something or 19 something, whatever you want to use. So I modified the code for that, and also made it a little bit more robust to typos, because if you set the clock and you make a typo, your whole machine would just crash. And that's also fixed. It will now not crash, it will tell you what to do again. As I said, I still want to have the possibility to reprogram an EEPROM and to erase it while it's on the board. As I explained earlier, there's this chip enable line which prevents the chip of the EEPROM working when the clock chip is not functioning. And you can bypass that by just a wire jumper for programming or for testing, whatever you want to do. So you can take out your real-time clock, or if you don't want to do that, you just can do something like this. Just connect 2 pins, and then it's also, the function is the same. I used the debug function in LDOS 6.3, which is a really nice function. It takes some use. You have to get used to it and how it works, but you can single step your code, and that's really nice. I couldn't find any function for it in the TRS-80 GP, so it's not yet emulated. At least not that I know, but maybe that's a future thing to come. Yeah, different button. Yeah, this is the way you fix it for reading and writing without using the real-time clock. And as you can see, the right-hand board has both chips soldered, so no sockets. And you can do, and the ROM chip is a EEPROM, a 2K EEPROM, which really fits the size of the normal Model 2 ROM. And there are no 4K EEPROMs. The next size is 8, and then you have some extra pins, so it will not work. But this is, I thought, a really nice solution. If you try to run it without the clock chip and you don't have it jumpered, you will run into errors like this. So it's immediately clear that something is wrong. And otherwise, your DOS will boot, and you can just type in the command. I named it CLK224 was the test version. And it will tell you, well, the smartwatch is not set, and the way you want to set it is type in a set commando with the time, the date, and the number of the weekday. And when you do that, you get a result like here. This is what you type in, CLK2 set, CLK2 set, and then the time and date. And the system will respond with, okay, you have set it to Thursday, September 9, with this timing. And the last two question marks here are the decimal seconds. It's the tenths of seconds that can be read out, but it cannot be set. And if you just type in CLK2, it will report back date and time, including, well, the decimal seconds. If you set time and date really at the end of the day, so 1 second before midnight, and you ask time again, you can really see that the clock is running, and it's jumping from Thursday to Friday, and from September to October, and things like that. So the crystal is working. It was the whole idea of this test, and the real-time clock performs its function. I have all documentation for this on GitHub, including also the images you can use on the GoTech with your Model 2. And the changes I made is system date off, system time off, so that you are no longer required to put in time and date when you boot. And an auto command for CLK2, which copies the time and date from the clock into the system time and date. So with this setup, the Model 2s will still use the normal timing routines, but at startup it will set the actual time and date, and from there it will continue. This means if you have programs running that mess up the timing, that still happens, but you can reset it to correct time and date by just typing in CLK2. You can also embed, of course, these routines in the system code for LDOS, so that instead of running by interrupt setting systems, it will always read new time and date from the chip. But I have not done that. That's a little bit more work. When time permits, and I will try to make a smaller board, which is a bit nicer, has a nicer fit, using SMD components. Add a verbose mode so that when you start up your machine, it will not report which time and date it is, but just do it without showing you. And I will try to put it into my diagnostic ROM chip as well. But currently I have only 20 bytes left, and that's not enough for these kind of routines, so I have to take something out. I'll also try it on different platforms like a Model 4, which I have, and also thinking about putting it into the original Model 2 boot ROM. There is plenty enough space, so I could put a routine in there where you can set the time on a Model 2 without anything running, so without floppy drives and without disk drive, hard disk drive. You just start it up, hold some key, and then start, and then use it to reset the clock. So that's the thing. And yeah, one of the things is on here is ported to NuDOS. In Europe, NuDOS is a very popular OS, more than LDOS or TRS-DOS. This is an example of the different versions I made. Over the left, that's a real-time clock with a 4K EEPROM. The middle one has a EEPROM and real-time clock in a socket, and on the right-hand side, it's everything is soldered in place. It's the lowest one, the minimal risk of hitting anything above it. And I have them here as well, so you can have a look at it. No problem. So thank you very much for your attention. Any questions?
Ruud,
Yeah.
what does it do if you have that installed and you boot something else? Does it just ignore it because you didn't set the right pattern?
Yeah. This 64-bit sequence, the chance that you have that created by accident is so small that it will just not happen. Yeah.
I didn't quite understand what causes the boot problem that you showed, like with the weird characters on the insert disk.
Yeah, the boot problem is caused by not having the output of your ROM chip enabled.
Oh, okay.
Because if you take the chip out, that chip enable line is floating, so it can be any value. So there's no.
I see. So it's only if you have the real-time clock removed from the socket. That would happen.
Yeah, if you remove the real-time clock from the socket, you have a floating chip enable line.
Good.
So that's why you jumper it by a wire or by connectors.
Cool.
Yeah.
You mentioned interrupts a couple times throughout the presentation. The first time you mentioned it, I was wondering if it was a hardware interrupt from the real-time clock chip. Because you said the designs were different, but then you talked about the operating system. Were you referring just to the service calls from the operating system?
Yeah, the service calls in the operating system are running on a hardware interrupt. And they are also fed into the real-time clock routines of the operating system. The real-time clock chip itself is not generating any interrupts here. It's just running independent of your machine. You only use it to store and have automatically modified time and date. Any more questions?
Have you figured out how much time a Sierra battery lasts? I mean, how often you have to replace it?
No, I have not tried it yet. But if these work, then I at least know 2 more weeks. Because they were set when I left. Yeah.
But you could, because you made it a connector, you could run a wire to someplace where you could put a CRT battery holder, so to make it easy to replace in the model too.
Yeah.
We kind of built that into the design.
Yeah, I mean, this is only a very short wire, but you could also make a longer wire and even have a switch in there if you wanted to turn it off. And you could do even, and that's I think why they designed 2 battery backup connectors, is have 2 batteries connected, and you can, when one is empty, you just replace it, and it will continue running. So I think it was a very clever idea. The other clever thing is the layout of the pins of this chip are very much in line with the layout of the pins for a ROM or RAM chip. So if you take this one and put it inside of it, what they did at National Semiconductor, you can sell it. And that was the way that this smartwatch that was sold by Tandy as well works. So I think great ideas in this little chip. Nice thing. Any more questions? Yeah?
How much is it?
How much is what?
You selling them for sale?
Yeah, I sell them. $20 was the price I had in mind.
How much?
20. 20.
I'll take one.
I said I have 3 here. 1 is already spoken for, so I have only 2 left. But they're easy to make. I mean,
Got one left.
there's- yeah. And for those who really want to make them on their own, I still have some bare chips. Okay. Yeah.
On the height problems that you had,
Yeah.
what exactly was driving the height issue? Was it to the next part?
Yeah. In the Model 2, the CPU board is the first board when you look from the back on the right-hand side, and it's located directly to a metal plate. Yeah. And of course, your Model 2 will also work when you move your CPU board one slot to the left. Then you have plenty of room, but that's not the way it was. You should do it.
And have you looked at the other, like Model 12 motherboard? I'm just curious if you looked at that prior to laying out.
Yeah, I think in the Model 12 you have enough room above the chips.
Would it be possible to maybe create a ROM switcher so that it boots, sets the time, and then switches the ROM and then boots the operating system?
Yes, that is possible. The thing is, of course, you cannot execute code from the ROM that will be swapped out and setting the thing, so you would have to start up. The routine would be copied to RAM, or copy the time into a location where OS can use it, and then continue. Yeah.
So are you saying that, I thought I had resolved it in my head at first, you have to execute the routines out of RAM, you can't be executing the routines out of ROM?
You can execute the routine out of ROM as long as that ROM is not swapped out. So like in a Model 1 where you have 3 ROM chips, 2 or 3 ROM chips, you can use one, have the code run in one routine and the other one will be swapped out. You will lose your ROM chip when setting or reading the clock.
No, I understand that, but if it's so when it does this switch, is there like a command set that swaps it back in? Or
Yeah.
is it just a single operation?
Now in software, so the CLK2 routine just will swap in or swap out the boot ROM.
Okay,
Yeah.
so I originally thought it couldn't be run out of ROM, but for some reason I was watching, I thought it could be. So you're saying it has to be out of not that ROM chip.
Not that ROM chip, that's exactly the statement.
Okay,
Yeah.
that was my first answer.
So with respect to the, replacing the batteries, is there a way to read the battery voltage from the clock chip so that you know when the battery needs to be replaced or which one?
The clock chip has some awareness of the battery voltage, especially because this clock chip can also be used in combination with the RAM, and it will prevent writing to RAM when the voltage is too low, but you cannot access it from software.
So you can't actually ask it which battery is low.
No.
Well, if the time goes away.
Yeah.
This might be a question for you and John. What would it take to get to work with Xenix?
I'm not the Xenix expert, so we have to sit together. It did not take me too much time to get it working based on the source code I had for Model 4 and the documentation. So maybe just a couple of weeks.
Yeah, we were talking about that earlier. It's not straightforward.
It's not straightforward, but I think it's very doable.
Who has the 80s?
Okay. Thank you.